All right, good morning or afternoon if you're joining us from overseas. This is Nathan and I'm with Stella, and we're going to talk to you today about building Agile generative AI applications on AWS and on the SaaS platform. So today we've got a couple great speakers lined up, some of our senior technical leaders. We've got our CTO here in the US, Yehuda Cohen, and then our senior solution architect from the AWS SaaS team, Ujwal Buga. Good morning, fellas. And we're going to talk to you today, try to get down in the weeds here on some technology. Gen AI and AI is a hot topic right now. So a lot of people are starting to do it. And at least what we've noticed is there's a lot of folks that maybe are new to how to operationalize the whole machine learning platform. And, that means making sure that your SaaS platform stays agile, innovative, fresh, so that you don't incorporate AI or, ML components into the platform, and then all of a sudden innovation slows. So it is a new area for some. So hopefully this is a great time of learning. Please, let's make this interactive. So if there's any questions, any specific kind of things you want to talk about, now's a great time to bring it up. The way to do that is just go to the Q&A. Post your question there. We'll be happy to address it. So go ahead and you type those in now, and we'll kind of catalog those and try to address those as we go. So let's get going here. Let me jump over to our PowerPoint. So again, welcome, folks. Today we're gonna talk about some of the general challenges, use cases, and then we'll get into it. And if we have time at the end, we'll talk about a case study, some next steps you can take if that's your inclination. So again, some of the challenges we have, skilling. Some of this is new. A lot of people are standing up ML, AI components and services on AWS, and they have a SaaS platform. And maybe they just haven't had experience how to operationalize some of these components, particularly in a multi-tenant environment, right? How do you keep different models synced? How do you keep the feedback loops working the way they should? How do you provide the individualization and the specialization for each of your different customers that are subscribing? And we'll talk about that more. And then, of course, data isolation and security, right? One of the gotchas, if you will, for security is, well, if I go out to, say, ChatGPT or a publicly available ML engine and I plug in my own proprietary data, have I just given it away? Well, of course, if you have a SaaS application and you architect it securely, properly with the ML operationalization in place, you're going to have a way to do that. So lots of use cases for AI ML out there. We won't go through every one, but think of all the natural language processing that can take place, medical transcription, the data visualization that can happen as you're processing real-time information or capturing data or analyzing it, image and video analysis, everything from construction to people and medical analysis, mental health, chatbots. This is something we could talk about at the end. Everybody knows about platforms like ChatGPT and Bard, et cetera. How can you leverage those inside your organization without giving away your proprietary data? We can talk about that today. Recommendations, automated design and creativity. And then even on the security side or on the build side, you've got test automation. You've got data generation for different models that you can even use AI for, and you can anonymize data and kind of scrub it so you can use it well. And then, of course, content gen. So with that, I'll hand it over to Yehuda Cohen. Yehuda's our CTO here in the US. He's going to kind of start talking about what to consider and how to approach solving the operationalization challenge with ML and AI components built into your SaaS platform. And then after, again, any questions? Am I seeing any here? Let me check Q&A. I'm not seeing any. Okay, so again, if you've got questions real time, type them in there. We'll bring them up. And with that, I'll hand it over to Yehuda. Good morning.
Well, thank you for that intro. I'm going to steal a screen from you here.
Sure.
Just confirm that you can see my slides. We'll get started. Nathan, can you see?
Looks
Yes,
good.
looks good. Yep. Sorry, I had to unmute myself.
Fantastic. Morning, everyone. Afternoon, evening for some. I'm Yehuda Cohen. I lead the engineering team at Seller US. I'm also an AWS community builder. I spent some time writing blogs, contributing to open source software within the AWS ecosystem. I've been building software and infrastructure for 10 years, at least 8 of which have been with AWS platforms. I actually started my career at Amazon. And more recently, I have a bunch of new exciting building blocks to play with in this Gen AI space. And I've started becoming very interested in it and learning a lot about it. I think a lot of this discussion is really speaks to the learnings that I've undergone over the last year or so, since really Dawley Stable Diffusion. But we're going to be speaking specifically about language models today and integrating them into SaaS platforms and some of the challenges along the way. So let us start off, there we go, with the reason that you're all here today, and that is that everyone wants to leverage generative AI technologies. And ChatGPT was released in November of last year. Today, there are over 150 open source language models ranked on Hugging Face's language model leaderboard, benchmarks these open source models against a set of open source benchmarks. We're still solving the benchmarking marking problems for these. It's not so easy to benchmark and determine how performant a language model is, but there are a variety of methods. And we are definitely seeing some really strong open source contenders. Over the last 8 months or so, since the launch of ChatGPT, we've also seen a ton of open source innovations, either in terms of language models themselves. Meta released Llama. You'll see that here that in my slide. I have it as a research-only language model, but just yesterday, since I assembled these slides, they actually released Llama 2, which is a commercially available option and is available in a variety of different sizes for different compute power and for different needs. These models benchmark incredibly well and out-benchmark most other open source models. It's been very, very, very impressive to watch. But the remainder of the slide just lists a bunch of innovations that we won't talk about. But the point that I really want to get out of this is that we've seen huge innovation in the data science space already within 8 months. Sorry about that. So the question is, if we've seen this much innovation in the data science space, and we've seen this much innovation in the data engineering space around ML operationalization or language model operationalization more specifically, why is it that we don't see so many generative AI-powered SaaS applications? And the answer is that integrating language models into product is very, very difficult. There have been, I think, 2 very successful startups who have successfully deeply embedded generative AI technologies into the platforms. There are, I'm sure, more than that, but the 2 that I'm aware of, which have built startups around these and have made a lot of strides into industry adoption, are Glean and Rewind AI. But the one thing to note about both of these is that they were founded in 2019 and 2020 respectively, and that is that they've been taking the last 3 to 4 years to deeply integrate these technologies even before the rest of us were using them. And undergoing a journey of integrating generative AI into your products is it's a big undertaking. And I think that the 4 primary reasons for this are that the first one is that machine models are very unpredictable. They tend to hallucinate. They might respond in misaligned ways, things which you don't want your customers to be seeing in your product. It's very hard to enforce structure on the responses of your ML models, and that also contributes to the lack of predictability. And in a SaaS platform, you want things to be smooth. You want your user experience to be seamless, and so ensuring that your language model is returning responses with the structure that you desire is incredibly important. The second is data security and privacy. When you're building a SaaS platform, you typically have lots of customers using that SaaS platform, feeding data into that SaaS platform. So you need to ensure that data does not leak between tenants, between users and subscribers to that platform. You also need to have access control mechanisms in place to say, well, maybe administrators should be able to see some level of data while regular users can only see a subset of the data. So achieving these in a language model world does not really, or we're just starting to see patterns emerging as to how to deal with those. And I think that both I and Ujwal will touch on some solutions to that. The third is, how do you incorporate feedback from your users and refine continuously these language models over time? How do you ensure that your product improves and your user experience improves, and that even if it starts a little bit rough around the edges, you're able to incorporate that feedback and align your models with something which is more desired from your users? And incorporating feedback requires a lot of operational components like data capture, as well as training processes surrounding training reward models. We'll talk a little bit more about that later on. And lastly, there is the infrastructure and operational challenges where, it's one thing to train a machine learning model to predict next tokens of data, to predict a transformer model. It's another thing to host it at scale and ensure that when you have all of your customers attempting to create predictions at the same time, it scales accordingly. So we're gonna, in this presentation, look at all of these four challenges, and we're going to try to offer some building blocks which you can use to solve them. One thing which I will stress is that there is no one-size-fits-all solution to these problems. Each SaaS application has different tolerances around security, privacy, what you want to show to your customer, and how you're using the AI model. And so what we will be looking at here is some considerations that as an architect you can use, and some tools that you can use to help alleviate some of these challenges. So let's start with model predictability. And in order to enable model predictability, we really have three tools which we can use. The first is to use high quality foundational models. Okay, so Hugging Face has a leaderboard of open source language models. We also have some leaderboards which try to rank how well GPT-4 and some of the more proprietary Anthropic, some of the more proprietary powerful models work. Looking at these and trying to find a model which is performance, affordable for your use case, as well as is high enough quality, is really important. But once you have that, even with very few examples of labeled data, you can fine-tune that model to provide answers and provide completions which are more aligned with your use case. So Sebastian Rudder and Jeremy Howard, in their paper, it's called, I think, Universal Language Model. I'm just putting up the notes. Yeah, Universal Language Model fine-tuning for text classification. They demonstrate that with as few as 100 examples, you can significantly improve the quality of your language model's output and align it to provide answers which are, or provide completions which are in line with your desired style of completion. Let's talk a little bit about structure, type, and quality guarantees. So sometimes you want to ensure that when a model generates a completion, it meets and it responds in a very specific form. And an example of that would be you want your machine learning model to generate a JSON structure such that it can serve as an API. So in order to achieve this, we have a tool, an open source tool called Guardrails. You don't need to use Guardrails. You can handle these validations yourself, but Guardrails is a pretty convenient way of achieving this. And in Guardrails, you can create an XML structure which specifies the fields, what to do, what kind of desired output you want from your language model, and what it should accept versus reject. And if it fails, do you want to re-ask the language model? Do you want to filter it out? So in this slide, you see an example where we explain what a background is in a tweet, and we return an explanation and a follow-up URL, where in the follow-up URL, we validate that follow-up URL is in fact a valid URL. And we also ensure that the explanation provided fits within the length of a tweet. And if it does not, then we're going to re-ask the language model and ensure that it does have the structure guarantees that we expect.
Hey, Yehuda. Travis had a question there in chat. Would there be difficulties with end user interpretability depending on how complex, in his experience, if the model's too complex, the end user won't understand and the model's not getting off the ground?
So let me take a look at this to make sure that I'm answering exactly correctly. So there are different models which are fine-tuned for different kinds of completions, right? So one model which I've seen, which generates very, very terse and unconsumable responses, which are very accurate, is Flan UL. This is Flan UL2, I believe. It's a Google model. It was relatively popular at the beginning of the year, and it provides pretty answers which aren't really all that useful in a non-scientific context, even though they're relatively accurate. And so I think a lot of user interpretability depends on what that language model is fine-tuned or tuned to create. So you have the initial language model, which understands the context from what you're asking. And then you have the completion, and the completion is going to be the next likely tokens to be predicted. And so if you've aligned your language model with your business, with, I suppose, what you want, with the style of responses, by fine-tuning it and saying, well, when we get this kind of input, we want this kind of output, then your language model is very likely to provide an output which is of a similar form and structure. And that, plus the level of understanding and the loss of the language model, is going to determine just how understandable it is and aligned it is with your users. Does that answer your question, Travis? I'll continue to monitor this, and okay, great. Thanks, Travis. Let's talk about data security and privacy. So when you train a model on sensitive data, governance around that model is very, very difficult, right? You don't know what the model is going to respond with. It's most likely going to respond with the correct response, whether or not you want that correct response is sensitive. And so in solving this, I recommend using retrieval architectures. Retrieval architectures have become incredibly common, and Ujwal will be talking a little bit more about those in his presentation. But at their core, retrieval architectures do not train the model with any sensitive data. During inference, you fetch the sensitive data and provide it to the model as part of the question. So we use search engines, structured queries, SQL. We use vector databases to query document embeddings, which you've stored into those vector databases to find candidate sources which are very likely to have the responses that you want. We then provide a query to the language model, which includes that context and says, well, from these documents, can you answer the following question? The model makes sense of the data and then provides a response using that. And this has a couple of advantages. The first is that you only need one model. The job of that model is to understand queries like this and respond and synthesize context to create useful completions. The second advantage is that in this model, when a user queries the model, you can use the user's permissions to determine what data sources that user has access to. And if and only if the user has access to a data set, you can include it in the context to the language model. And lastly, retrieval architectures aid hallucination, because you've told the model, we want you to answer, but only include the data sources which we provided in that answer. And so the model is less likely to make something up which is inaccurate. Let's talk about reinforcement learning and fine-tuning and incorporating user feedback into your model training. And there are really two ways to incorporate feedback from users. The first is to say, well, we're going to label very useful examples, things which we think are representative of what the model should be doing. And we're going to very, very aggressively align our model with that type and style of response. And we're going to do that by fine-tuning the model. But there's also a special type of fine-tuning, which is reinforcement learning from human feedback. And that is that you collect lots of little signals from your users about what's considered a good answer and what's considered a not good response or completion. And so in single model architectures, feedback is challenging because systems need to exclude private data from challenging. So taking that user feedback and using it to improve the model is not as easy. This kind of improvement also requires significant investment, as you need to first make sure that you're collecting the data sources. Secondly, ensuring that you have a good definition of what's considered good responses, good completions versus poor completions. And you also have training costs. For some of those training costs, leveraging parameter efficient fine-tuning techniques can lower those costs, but they are still relatively expensive. And if you're going to train a single model for each tenant, because each tenant requires their own customization, that is challenging. Okay, let's us talk about what reinforcement learning from human feedback actually looks like. So this is taken from TRL, which is an open source library. This is from the README empty. It's an open source library, which it stands for TRL, Transformer Reinforcement Learning. And it really was one of the first open source libraries to enable everyone to use reinforcement learning on transformer language models, the kinds that ChatGPT, Anthropic's Cloud, Llama are all based off of. There's really three stages of reinforcement learning. The first is that we need to capture those queries, feed them into the language model, and get their response. So in this case, the prompt of the query would be, the movie is, it goes into the language model replies really great. Then we take the output of that query, we take the query and the response, and we feed it into the reward model. Okay, a reward model is a model which we create based on our own business domain, which says, well, how good is this response really? And we assign a reward to that model, and that'll usually be a number between 0 and 1, where 1 is very good reward. We really like this completion. We want more completions like this. And then what we do is we go through an optimization process. We take lots and lots of query and response pairs, and we feed them to two language models. The first is the active model. That's the model that you're currently training. The second is the reference model. The reference model is the model which it's effectively a baseline model that you don't want the active model to deviate too much from. So you provide the query and response to both of the models. You then calculate a set of log probabilities which are outputted from each of the different models. Those log probabilities are then, we determine what's called the Kale divergence, which is how different are these models. We're really determining how different is that active model from that reference model. And if it's very different, we're going to penalize it. If it's more similar, we're going to keep it close. And the reason for this is that, as opposed to regular fine-tuning, we don't want our user feedback to super influence the machine learning response. We only want it to provide a little bit of an improvement. And so we take that reward component from our evaluation, but we also ensure that we add an additional component to that reward, which is that Kale divergence, and we create a new set of gradients which we're going to reincorporate into our active model. And if it was a good, we consider that query response to be very good, we will incrementally adjust our active model to slightly more frequently use that sort of completion when provided with a similar set of tokens. And so reinforcement learning from human feedback is a type of fine-tuning. It's just that the fine-tuning is not meant to aggressively align the model. It's meant to very, very incrementally update that model for every query response pair, which it undergoes during the optimization process. Finally, how do we deal with the infrastructure and operational challenges of hosting these models? And to that, I would say, if you're building a SaaS application, the last thing that you want to be doing is hosting EC2 instances, worrying about scaling those, and understanding how what infrastructure and operational patterns you need here. And so I would say the best guidance I can give you is to leverage AWS managed services, serverless technologies wherever possible. We have lots of different building blocks. Sorry, I just see a question here from Travis. Okay, so the question is, how is the reward model made in the evaluation step? And the answer to that is that you need to collect signals from your users. Okay, those signals are going to, effectively be labels where there's a prompt completion pair and the user says, well, this was helpful to me. Or maybe the user does an additional action, which you can infer, from which you can infer that the query and that the prompt and completion pair was a valid one. You then train a standard machine learning model on those labels. And that machine learning model is going to be tasked with, given a prompt completion pair, does that constitute given a specific input, is this completion good? And that's just effectively a classifier. It's a standard machine learning classifier. And so that reward model is effectively a machine learning model, which is trained on your users' feedback. Your users are classifying prompts and completion pairs as valuable or invaluable. And the reward model is going to be trying to classify prompts and completions in a similar way to how your users already have, by using standard, I suppose, gradients based classifying models. Does that answer your question, Travis? Yeah, great. Okay, so let's talk about integrating, how we achieve some of these operational challenges using AWS's serverless technologies and managed services. So in order to host models, AWS currently provides Sagemaker endpoints. Sagemaker endpoints are, there's currently an integration with Hugging Face, which you can think of as GitHub for open source models. People upload open source models to Hugging Face, and you can then deploy them to your AWS account using Sagemaker endpoints. There's a tight integration that makes it very, very easy. These Sagemaker endpoints, unfortunately, cannot be serverless Sagemaker endpoints. So the reason for that is that serverless Sagemaker endpoints currently do not support GPUs, which are powerful enough to run most of these models. But you can use regular real-time endpoints and back them by GPU AWS instances. And with that setup, AWS will take care of ensuring that models are online, that you're able to query them when you want to. You'll be able to monitor those models. You get a lot of that built-in monitoring for free. For retrieval, you have all your regular full text search solutions, your databases, but you also have vector search solutions. In RDS, Postgres supports the PG Vector plugin, which enables you to use your RDS database to store vector embeddings for your documents. And OpenSearch supports its own KNN plugin also for the same purpose. To incorporate feedback, that really is use case dependent. You're going to need to build data pipelines, training pipelines for you. You have the Sagemaker suite for model training, for Sagemaker pipelines. You have S3, DynamoDB, step functions if you want to do very advanced orchestration. You have SQS for long asynchronous tasks. You have Kinesis to stream, to collect data from your users if you're expecting lots of data volume, which you need to transfer to train your reward models. And all of these in conjunction support a very, very powerful serverless foundation. You can use this to build those training and feedback mechanisms that you need to incorporate feedback into your language models. And lastly, Amazon has released or has announced Bedrock, which I think is coming soon. And Bedrock is going to enable a fully managed serverless user experience whereby users can pay per token, per the amount of data that they're feeding into the models, that they're retrieving out of the models. There will be that solution where it will scale for you. You will not need to worry about scaling at all, monitoring and understanding. All of that will be taken care of by Amazon, and Bedrock will enable you to use many state-of-the-art language models, including Anthropic models and other very powerful open source models. I'm not sure about Llama 2. It was only announced yesterday, but I would expect that that will become a priority for the Bedrock team as well. But there will also be AWS's own Titan model available for you. And these will all be available natively within the AWS ecosystem. You'll be able to assign permissions most likely with your familiar IAM resources. I'm guessing that there will be support for VPC endpoints. We'll see as it's released, such that you don't have any requirement for any data to leave your security boundary or your network perimeter. That's it for me. Thanks everyone for listening. I see there's a question from Deepashnu, which is, can you provide any tips or advice for developers or teams who are considering integrating language models into their SaaS products for the first time? I think that, to me, the most important tip that I can give is use a tool like guardrails. You want to ensure that your model's output is as predictable as possible. Chatbots are relatively freeform. You probably can get away without that predictable responses, but if you intend on doing anything where the output of the chatbot is going to be used for computation, you want to make sure that the outputs that your users see are very much within the parameters that you've set up. If you wanted to generate code, for instance, you could use guardrails, provide some built-in validations. One would be, does this code actually, is it interpretable? Is it valid code? And so tools like guardrails will enable you to do that and ensure that that user experience isn't incredibly frustrating for your users. There's nothing worse than providing a SaaS product which generates code if that code is not usable by those users. And so keeping that user frustration down by ensuring that your SaaS product is as predictable as possible is very important. So that's, for me, the most important thing. And the second thing which I would say is there are tools which are available for orchestration. I think Ujjwal will touch on some of those, which means how do we fetch data from databases? How do we submit that data to language models, and how do we handle all of that complexity? Those tools are and do make things easier. But if you're struggling with those tools, or if your use case is a little bit stranger, you can build those chains yourselves. Those tools like LangChain, there is no magic happening. They're convenience methods, and you shouldn't overly rely on tools like that. Does that answer your question, Deepashnu? And in the meantime, I will go on to Vijay. Great. So Vijay asks, when it comes to RLHF, is that what OpenAI is doing with the feedback buttons for the individual prompt responses? And how much feedback collection would be considered big enough for model training? The answer to the first part is yes. That's exactly what OpenAI is doing. That is why ChatGPT was so much better at question answering than anything else we've experienced. But to the second question, which is how much feedback collection would be considered big enough for model training, I think the answer is very use case dependent. Your reward model needs to be tested on and validated against your own, against the queries and responses that you submit to it. As long as that reward model is providing and is classifying and is classifying prompt and completion samples with the expected, I suppose, accuracy, then I think you're in a good place. That reward model is really the key there. So however much feedback collection you have there helps. And I think that the answer is that the feedback, that you can do a lot with a little bit of feedback, but there's diminishing returns as you increase more, as you collect more data, that loss will only slightly reduce. But even that slight reduction can be very meaningful depending on the product in question. Okay, great.
Cool. Yeah, so let's keep moving. Ujwal, glad to have you with us. Ujwal, again, he's the senior solution architect with AWS in the SaaS program. And he's going to get a little more down in the weeds in terms of implementation and some examples. So some of these questions may get answered here. So, but I think what we may do here, Ujwal, is we'll hold questions till the end. Does that work for you? Unless you see one come in that you want to do, and then we'll hit them all at once at the end. So, all right. So, hey, Ujwal, and I'll just turn it over to you.
All right. Thanks, Nathan. Let me share my screen here. Let me go into the presenter mode here. So, Nathan, can you confirm you still see my screen, right?
Looks great. Yep.
Yep. Sure. Thanks. Thanks, Yuda, for that walkthrough. What I'll do next here is walk you all through, introduce you to what are the different types of, some of the types of applications you can build using these GenAI services, and then briefly talk about a few patterns, a couple patterns which are emerging in this space where people are building SaaS applications using these services. And then try to talk about how you need to think about building your architecture in this space where it can provide you the scale and the required agility when you're building the SaaS solutions. So with that, let's jump in here. So when you're building applications in the GenAI space, what you usually use a foundation model, which is a large language model, which is pre-trained with corpus amount of data, and it does broad range of tasks, which I've outlined here is like text generation, summarization, chatbot. Based on these, you can build applications. So out of the box, it can do a lot of stuff for you already. But the challenge, or the thing which you usually see here, is that it is generic enough. It does not apply specific to your organization or to your customer. And that's where the first pattern would come in when you're building, when you're talking about building a SaaS application, where you build a model per each tenant or per each customer. So what you do in this pattern is basically you take this base foundation model and then feed it with the tenant specific data, and then create a fine-tuned model specific to that particular tenant. So basically you build an infrastructure where you pull in this foundation model and provide the infrastructure where you could feed the customer specific data or tenant specific data, and then tune this model specific to that particular tenant. That's one pattern where we call creating a model per each tenant based upon your tenant data. And the other pattern which Yuda kind of touched upon a little bit here is using a RAG model, which is nothing but a retrieval augmented generation. So here from a SaaS angle, what you do is you take one foundation model and you feed it with customer specific or the tenant specific data to it, so that it does the job for specific to that particular tenant. I'll walk you through this whole architecture, like basically the RAG approach. So the way I'll break down this architecture here is the way the RAG approach is implemented is if you look at the step one there, first what you will do is you take an embedded model and feed it with your documents or your data, and it creates embeddings out of your documents. These embeddings are nothing but the numerical representation of your text. And then these embeddings will be stored in a vector database. Like as Yuda mentioned, this vector database can be an open search database or RDS Postgres SQL, or it can be another other third-party databases like Pinecone, etc. And once you store that vector database, once you store these embeddings in the vector database as shown in the step 2, Then from an use case perspective, if you move towards the step 3, where user comes in and provides you the prompt or the things which he's looking for in a chatbot or an admin UI, and that request would flow to a step 4, where you have some kind of a Lambda function which acts as an LLM orchestrator. So what it does is it takes the input prompt from the user, and then with this input prompt, it hits the vector database and gets the additional context which you stored in that database in the previous step. So, and then change that additional context to the input prompt in the input prompt, or the input prompt which you got from the user. So basically what it does, it changes the input prompt and the additional context from the vector database. So to change these, what you can use a framework called LangChain, where you kind of like you chain all these additional context to your prompt, and with the whole chain and the request, it will try to hit your large language model in step 6, where the language model uses the prompt and the additional context and to answer the question which the user has asked. So here, that's the typical RAG model. And if you look at from a SaaS angle, you have one model which is shared across all your tenants. But the thing which is different or specific to your tenant is the data stored here in your databases. And the thing which we need to make sure that for a given request of a particular tenant, that particular tenant is only able to access that particular data particular to that particular tenant. And as Yuda mentioned a little bit, so Amazon has a new service called Bedrock, which is in limited preview right now. This Bedrock will help you to implement the patterns which we just talked about, and also it basically to the Bedrock, it opens up and you can use the APIs to interact with the foundation models to build your GenAI applications, and it opens up for you to interact with a bunch of foundation models. There are a couple foundation models which are provided from Amazon, and there are also you can also leverage the foundation models from some third-party vendors like AI21 Labs, Anthropic, or Stability AI. And using these foundation models, you can privately customize your foundation models specific to your organization data. Not only the Amazon Bedrock, even we can use another service called Amazon Sagemaker. Within the Sagemaker, also there is a Jumpstart feature where you could access some of the third-party models out there. So when you're dealing with when you're building applications in this space, what you usually have is like you different steps. You need to obviously fine-tune your model, or to fine-tune a model, you need to prepare the data, train the data, and then deploy that model. And after you deploy, you need to monitor that model. So this is a typical ML life cycle. And when you're building these SaaS solutions, you have to build an architecture which can streamline this whole ML life cycle. So the reason why you need to do is, obviously, when you build your SaaS application, you need to think about the agility and the scaling of your architecture, because you want to be in a position where you can easily onboard multiple tenants, and your architecture should be scalable. So with that in the thought, if you work backward, what you need to see that what are the different things which you could automate. The one thing you could obviously automate is the ML lifecycle, which I just mentioned. So to help in this space, again, Amazon, you can leverage Amazon SageMaker features. So one of the Amazon SageMaker feature is Amazon SageMaker pipelines. These SageMaker pipelines can automate your preparing of the data, training your model, evaluating your model, and deploying that model into the production. And again, once you deploy the model into the production, SageMaker also provides you another feature called Model Monitor, which can monitor your model and say, hey, if it is drifting or deviating from what you're looking for, you can trigger a process where it can again trigger the SageMaker pipeline, where it can retrain the model and then deploy that model to the production. And again, when you're talking about using these models, sometimes you create multiple versions of these models. You need to have a mechanisms to maintain these versions and maintain these different models. And again, you can leverage another feature of Amazon SageMaker called Model Registry, where you can register these models. So what I'll do next is I'll try to give an example of how how you could leverage some of these SageMaker, some of the features which I just mentioned, and how you need to think about building an architecture. So this is an architecture which I pulled from a workshop which we built. We can provide you the links of this workshop if you're interested to go deeper into it. But this workshop is specifically talking about how you need to build an architecture if you are trying to address the use case or the pattern of building a model for each tenant. I know there is a lot of going in this architecture, but I'll try to break it down piece by piece here. Let's first concentrate on the down portion of this architecture, that is the tenant architecture. I'll get back to the top portion later. In the bottom portion, under the tenant architecture, let's move towards or concentrate towards the right-hand side where it has a SageMaker pipeline. As I mentioned earlier, so this architecture is trying to create a model for each tenant, and we are leveraging the SageMaker pipeline here to train the model, to evaluate the model, and store the version of the model in the model registry, and also deploy the model. And that's what the whole SageMaker piece on the right hand side is doing. And the rest of the front piece, what you see from the training to the SageMaker pipeline, is an infrastructure and architecture where it provides a way where a tenant, particular tenant, from a user from a particular tenant, from tenant A or tenant B, as shown in the architecture under the training heading, can upload the tenant specific data through an API gateway, and that the data will be uploaded into an S3 bucket that triggers an event in the event bridge, and that triggers the SageMaker pipeline, which would take this input data, train your model, and creates a model for each tenant. And in the bottom portion of that architecture, for the inference, again, a tenant with after the authentication using the JOT token, they would invoke this API gateway, and when they are doing the inference based upon the tenant information in the JOT token, it you could invoke only the model specific to that particular tenant. And coming back, and again, in this tenant architecture, which I've breezed through quickly here, at every point of this architecture, there is proper guardrails to make sure that a particular tenant can invoke its tenant specific resources or tenant specific data. And coming back to the top portion of this architecture, we call a SaaS control plane. You need to build a SaaS control plane which would allow you to onboard or provision this tenant architecture. In the sense, what you usually have is you could create a basic tier and a platinum tier. Basic tier, you can say that hey, when I try to onboard a basic tier tenant, I would provision this tenant architecture in such a way that it will there will be one tenant architecture which is shared across all the tenants within this basic tier. And if you try to onboard a platinum tier tenant, you would through this control plane. This control plane should onboard this tenant architecture specific to that particular tenant, which will be used only by that particular platinum tier tenant. I know I've covered a lot of things here, but you can see the point here that the architecture is scalable enough and it is agile enough where it will allow you to easily onboard your tenants, and also it can scale easily. And again, I totally understand that this is a generic architecture, and there will be your architecture is specific to your use case. But again, the point I'm trying to drive here is to think about ways which will help you to scale easily. I know the leveraging the services out there, you need to shoot for the scalability and agility. You don't want to be in a position where you get a lot of customers and you cannot onboard them quickly. And also from not only from the onboarding perspective, but also from the operational point of view, you need to make your job easier so that it is easy for you to maintain or provide a best service for your onboarded customers. And finally, I wanted to summarize the things here in a bit from a SaaS business perspective. We talked about briefly about the SaaS patterns and the different services you could do and how you can build these solutions. But end of the day, you need to think about how would you enrich your customer experience. So that's all it matters, right? End of the day, you need to provide some value to your SaaS business, and think about what makes how I could leverage this GenAI application to make better customer experience. Like for example, it can be an example where you could put a chatbot, we can summarize the things. Or if you have an e-commerce application, you have a lot of products where you have a lot of reviews, you could build some kind of a tool where it could summarize all these reviews and provide you some meaningful information to the customers. And think about those use cases where it will enrich your customer experience. And another thing or the other angle of looking at how you could leverage these AI ML services is, I know as of until now, we talked about using these generative AI or AML or ML services to build your SaaS solution. But the another angle to it is use these services to apply to your SaaS solution. What I mean by that is, once you build your SaaS solutions, you onboard the tenants, and your tenants will start using your application, and you get a lot of corpus amount of data about how the tenants are using your data, and try to see what are some of the AI ML services you could use and to do some analytics around that customer data and get meaningful insights out of that. The meaningful insights could be like, hey, how are my tenants or how are my customers are using my system, and which particular type of features are they using most. Based on that, you could you could improve your go-to-market strategy, or change your go-to-market strategy, or change your pricing and packaging approach. So yeah, think about not only just to think about that, leveraging these services to just build a SaaS application, but also try to see how you could apply these within your SaaS application to make your service better. So yeah, those are the things which I wanted to share with you all today, and I'll push this over to Nathan, and I'll be happy to answer any questions. Let me come back to my video here.
Yep.
Yeah.
Yeah. Thanks, Ujwal. So yeah, we're kind of running up here in the end. So if you've got questions, go ahead and post those in Q&A. I think Francisco had one, but it looks like YC or Yehuda, we call him YC. Yehuda may have answered that already. So so thank you, Francisco, for that question. Yeah, I'll throw this out there for you, but if this is interesting to you, if you've got a use case, I think somebody said, hey, I'd love to incorporate some of this in my full stack app. There's a couple ways you can do that. One, reach out to us individually in those emails there, and ask us questions. There's a couple programs that are available to help you get there. One, you could schedule a workshop with us. And we could work with AWS to schedule a workshop, and some of those, I think actually some of your reference architectures, Ujwal, I think those were from the workshop, right?
Yes, they are.
So, maybe we could run through that workshop with you, be happy to help there. And then also AWS has a lot of funding programs that Sell is very happy to engage for you. We have some solutions such as a chat bot. If you've got a knowledge share that, you don't want to release your proprietary information out into the public, but you want to build a chat bot, we've got a nice solution that's very easy to prove out, built on top of your knowledge share. So I don't have, we're running out of time here, but very happy to show you how that might be applicable to your situation. If you're, regulatory company, looking up healthcare regulations, looking up FDA regulations, et cetera, and you want to protect your proprietary information in terms of regulatory compliance, best practices, we can certainly help you do that. So any other questions as we kind of wrap up here out there? Any parting comments, Ujwal or Yehuda?
Nothing, just thanks to everyone for coming, and thanks to Nathan and Yosef and the rest of Sarah, the rest of the team here for organizing this and ensuring that we're able to make this happen.
All right.
Yeah, thanks for the opportunity, and glad to share my findings or my research here.
All right.
Thanks for the opportunity.
All right. Thank you, gentlemen, and we'll see everybody later.